Hey there, this is TJ of ShopBot Tools, and welcome to today's training. Today we're going to look into the specifics into the profiling toolpath, and some of the advanced options in there. And to make it project-based, got this little marble track game here, where we drop these marbles down in, and if you can see, the marbles can't fall out through the front because they've actually been put in there with a little keyhole slot. So that leads us into some of the advanced options we're going to look into, like adding a lead in and a lead out for the cut. We'll also look into the order of the cut, ramping of the bit, how to tab these pieces so they don't move around, and then also the order, ramp, tab, lead, and we'll get into those here next. So thanks for joining us today. Alright, well the first thing we'll look at here is ordering of the parts, and this is where we're able to go in and select how we want the order of these to be cut. And we're just looking at a typical VCarve profile or a Spire file, and here we have our parts that we're going to cut. We have them all nested into our sheet. So over here on the profile toolpath, the toolpath operations, the very first one is profile toolpath. And a lot of you might not have this advanced shown, where when it's not shown, what you're looking at is the tool, the machining the vectors, and then you have a ramp and a tab. And we'll get into ramps and tabs throughout this training. But when it's advanced here, there's other things that we can add in. Notice now we have tabs, leads, ramps, order, and then even corners. There's different things we can add in. So let's look at the order real quick. What the order is we're able to click on this, and you can select these different vectors and approach the direction of the cut how you would like. So it could be the vector selection order, a left to a right, a top to a bottom, and just to demonstrate that, I've already calculated a toolpath here where I have the order from left to right. So maybe I have a setup out on my ShopBot where I have a vacuum system where as I cut from left to right I can turn zones off as they're not needed. So let me dial this down here in this preview, and we'll preview this toolpath, and as you see it's working from left to right. So on a typical 4x8 setup, as it got to the halfway point down in X, I could turn off zone 1 and 2 and put all the vacuum focused on the back half, zone 3 and 4. So that would be an issue. That would be a way you would want to select order. Another one is when you come in here, you could do bottom to top. You could have it try to calculate the shortest path for you. And then another one is vector selection order. So if you really wanted to get into dialing in your parts and the way they're cut, is you could do a vector selection where if you had that selected, it's going to go in the order that you select these. So by holding the shift key down, you select these, and it's going to remember the order that you selected these in. So, you know, something like this where you're jumping around, selecting here and then over there, that's not going to be very efficient because you're going to have your machine cut these three, have to pick up, travel above, go down over here, pick all the way up, travel here. You got a lot of back and forth going on. So there might be times where you need to do that with specific cuts, but just so you know that you can order your cuts right here. Alright, the next thing we're going to look at here is tabs. And tabs are what hold the finished piece to the scrap piece. And we'll see these cut here in a minute on the video. But just to understand what they are before we go to seeing them is you can see that I'm using a utility knife here to nip out this remaining wood that the software in the machine has left. But that remaining wood has been left there on purpose because otherwise that small piece could flounder around and end up cutting, the bit could end up cutting into your finished piece, or you could move the board enough that it would snap your bit. So here is our project that we're looking at, and you can see that it has this little T on the top and the bottom, and that's for the tab is what that means. And right here again underneath our profile toolpath is we have an option here where it says to add tabs. And what we're doing is we're being able to tell it what length of the tab we want, the thickness of the tab, which is also the height, and then also if we want it in a 2D or 3D. So just to kind of look at an edge view of our board here, we're looking at the thickness of our board, which is a 1/2-inch board. Here's our router bit coming down into the board to make its pass through, and here's our router up top. So if this router was coming along making its pass, if this was a 3D tab, which is what we have checked right now, the machine would actually ramp up and then ramp back down, and then just keep moving along and making the cut. And that's how that would leave for a tab. If we uncheck this over here and had it to be a 2D tab, now what this vector is going to do as it moves is it's going to come along, kind of needs to stop, pick up, go along, stop, drop back down, and so you got a lot more starting and stopping with a 2D tab. I have found personally that these 3D tabs work best with wood, plywood, and when you're cutting certain plastic, especially like HDPE and stuff, a 2D tab works a lot nicer. So those are the two different types of tabs, and you will have to find out lengths and sizes, lengths and widths that work best for you. But besides knowing if you want a 2D or 3D, tab placement is crucial. So if we can see right here on this apple that it has put the tabs in 2 spots here, and just to preview this for you in 3D, I'm going to preview out this apple. There does the V-carve first, and it goes around and does the profile, leaving in these tabs. Now these tabs are important because we need to hold this finished piece to the scrap. But what we have here is we have these tabs in 2 very inconvenient spots. We just used a precise CNC machine to cut these to the exact size that we want. Now we've got a tab located down inside this little area where we're going to have to somehow nip that out of there, and then we're going to have to somehow clean that up with a little file or sander, or try to get down in there and finish that. So tab locations are crucial. And so what I would actually do with this guy is I would come back here to my profile toolpath and I would edit the tabs, and instead of just having it add tabs where up here, I'm going to come in here and add tabs to the places where I want. And I know I got a little disc sander and spindle sander over here that I could get to these outside curves real easily. So I'm just going to put 2 tabs opposing each other, and then that would be enough for this project here, just cutting it out of thin plywood. So take into account 2 grains of wood. It's nice to have a tab going with the grain. It's easier to nip out. You'll see that here in the video. But also it might need the extra strength, so sometimes you put it against the grain. So I would recalculate this and reset the preview, and now I can go, oh look, my tabs are in a lot more convenient areas, a lot easier for me to clean up post being on the machine. So tabs are an important part of the advanced part of your 2D toolpath. The next feature in the advanced part of profile toolpathing that we're going to look at is called a lead. And you can either lead in or lead out of a cut. And there's several different ones. The one that we're going to be looking at on our project is we're actually going to be using a keyhole bit which slots down underneath. So where that bit starts, it cannot plunge as part of the project because that would make this groove too large. And there's other examples besides what this keyhole is. Certain bits will have different radiuses built into them where they're designed to actually put a round over on your material. So if you were to plunge straight in, you might snap that part over. So let's just look at this in the V-carve Pro software before we go to the video demonstrating this. So what I have here is just simply 2 rectangles, and I went in here and I've created my 2D toolpath. I'm just cutting through to the thickness of the material, which is my Z. I just have my bit in there. Nothing's out of the ordinary except over here where I have leads. I've now gave it a straight line lead, and I can give it an angle on which angle to bring it in. If I want to bring it straight up from underneath, if I want to bring it from 90 degrees to the edge, I can give it a length. Maybe I need to have it start off my material, which is what we'll see next in the video. For this on just the CAD right now, I'm going to leave it in just to show you why you'd have it in. So let's take a look at what a lead does. So let me calculate this one. I'll turn down the preview speed, and what you can see here is, what you can see on this guy is it's going to preview this lead. See, this is a line that wasn't even on our 2D drawing. That's the line that we gave with that lead option added on. So if I go to preview this, it's going to start right there. Preview visible toolpath. See how it starts out away from your part, now gets into the cutting of your part, and then we'll come back around. And we could also give it an option to lead back out if need be. Now that did not have a lead out, that ended right there. So that bit would have picked right up, which on our example of our project that we're going to be working on, this would not have worked. This would have either broken the bit or wrecked our material. So what I'd have to go back in here to this lead and have do a lead out. So I'd want to make sure that it was leading back out, which there it's checked. It leads in, it leads out. The next toolpath is, instead of have the straight line lead in, I'm actually going to do a circular lead. And with not only with the circular lead, you can set the radius, you can set the lead length. So same sort of thing. We'll come back in and preview this toolpath, and now you see it's going to do it at a circular. Preview this visible toolpath, and it leads in at that circular angle, completes the path, and leads back out. So this works good for this, and this is nice because not only can you have it lead in and out on these options, but you can also have it where it says an overcut, where you could give this a distance of whatever maybe the diameter of the bit might be to overcut past. So it cuts past where it started as well, and will help you get just a cleaner cut on there. But usually with your sharp bits, your machine dialed in, and a good ramp, which we'll show you in the video, you don't have to worry too much about this overcut. But what we're going to be showing in the video is we cannot use just a straight lead here into the material. My lead actually has to start either off the material, or I've had to make another toolpath ahead of time. So with that being said, let's step away from the software here for a second, and we'll look into a project which applies tabs, leads, ramps, and orders all into making it a more efficient cut. Alright, what we're going to get into next is we're going to look at the file for this, and then we're going to watch this thing actually be cut. And then I'll pause the video of this being cut throughout and go back to the file and show you how what the machine is doing ties into what we told it to do in our Vectric software. So this is where we're going to move. As we can see, we got some pockets going on, some profiles, some alignment, and let's move right into the file and see this guy. So here's what this looks like being drawn. I have just a regular job setup. I have a board that is 8 3/4, and I have it 24 inches long. It's a thickness of 0.83, and I've come over here and I've got my tool paths. And notice they're not all profiles, but some of the things that we'll be showing are going to not only be used in profiles, but also used in pockets and other things like ramps and stuff. So order of the cut is crucial over here, and when we start playing the video, I'm going to come back and show you each one of these. So this guy here is our 2D view, and we've got just the different areas. Here's our base with a pocketed out slot. Here would be our slot that's going to go down in there. There's a big dog bone because it's cut with a 3/8 bit. We can see where our marble track is. We have multiple lines on here, and you'll see why here in the video. You have a circle here where this is going to be pocketed down for a lead in, and we also have down here where the lead in or lead out starts off the material. So with that said, let's look at the video and see if we can see more about why this file is set up the way it is. Alright, we'll start here with a full screenshot, seeing the ShopBot in action. So this just to show you, this is on a 4-foot by 8-foot machine, and the way I have it is up in the front corner. So this is just a full screenshot, and then we'll dial into starting the file just like it's drawn. And again, the dust foot is only removed for demonstration purposes. You want to keep that on, keep your dust collection always sucking up the sawdust. So here's where we started. We've got our hold down, we're held to the table, and we're going to run our first two files, with parts here, which is we're pocketing down. And you notice here it's got a small little ramp, and we'll look at the ramp here in a second, but it ramped down to the distance, and then it just goes ahead and it finishes the tool path. So it's given a distance. Instead of plunging straight down in, that Z goes back and forth to a distance that we have told it to, and then it goes ahead and finishes its cut, cleans that out, and then it'll go ahead to the next pass depth that we set. Again, ramping down in, completing that depth, and then cleaning out where the ramp was. So The first two was a pocket of 0.5, and then the third cut here is a pocket that's not quite as deep. It's only a 1/4 inch deep, but again, same thing, it had one little ramp. So before I move on to the next part, notice how the machine is now moved off the bit, off the board. The bit is now hanging off here in -0. So let's look at that on this. So the first thing that we had was we had a pocket 0.5, which we had a ramp, which is going to ramp down versus a straight plunge, and we'll go into that a little bit at the end. We had another pocket, which was down here, which was only a 1/4 inch deep, and again that had a ramp. But what we're going to focus on today is the profiles. So the next one that it's getting ready to set up is, we saw that it moved here in -0 to start this slot. And just to look at what the slot is, if I click on this and I zoom in, notice that I have 2 vectors selected versus 1 down the middle. Well, what we're about to do is we're going to stick a keyhole bit or a little round over bit down in there. We'll do both, and it's going to make a slot that will keep that marble from falling out the front. That way it can only be entered or exited the material through the top or the bottom. So what we're going to do in this video is I'm going to make a little bit bigger slot up here for width, because when I come down this middle here, which is right down the middle of the slot with my keyhole bit, it has a shaft diameter of exactly 1/4 inch. So I've done a couple thousandths offset to each side, so when I plunge my bit down in there, it will not be rubbing the shaft up against the wood, and you'll see this in the video. But let's see what I have got here. For this one, instead of adding a lead to it, since this is not a rectangle, this is just a profile on the line, the lead option is really obsolete here. So what I did was I drew my line longer. So I'm making the same thing as what this would be clicking on here and adding a lead. I've just created my own. So here where I'm starting off the material, that's fine. It'll plunge down to 0.5 and then stick into my material, versus coming up here and plunging hard down into the material. And then up here where it's going to come out at 1/2 inch, well, this here has already been pocketed out from the previous toolpath. So that's already gone. If I check that out in blue, we've already seen that be pocketed out. So that part we're good. And then this is not need to be ramped or ordered because it's just simply going to be slotted through. So let's take a look at this one and we'll come back to the next step. So if I play here, what it's done is it has a couple different path lengths to get to the depth. I'm cutting this out of maple. It's a hard wood with a 1/4 inch bit, and I'm going back and forth in these zigzags at pretty good speed. So instead of plunging down to the full 1/2 inch depth, I'm just doing it in past depths that I have set, and it's going through and doing those. And then like we showed you, there's 2 vector lines right here. That way it's not just 1/4 inch slot that we put in, it's actually 0.227 of a slot. It's a little bit bigger, and here it steps over just a little bit to run it. And this would be really important for you to have an upcut bit to be pulling the chips out of here, have your dust collection going so these chips aren't going all over your shop and up in the sawdust in the air. But notice how it exits there in an area that's already been pocketed out. And that's what, same thing it's starting. It's starting over off the board. Wanted you to be able to see both examples. A lead in where there's off the material, which sometimes you'll want to do. And then the lead out, well, it's in the middle of the material, but I still need it to pick straight up. Well, that way I can put a pocket there and temporarily make it. So it's cleaning out this nice slot, because I'm about to stick a keyhole bit down in there, and I do not want that bit, I need that bit to have clearance for sawdust. I want it to have room to move around. I don't want it to be so tight in there that it's going to bind and not be able to complete the cut. So finally it's going to go and make its last pass, and I've really just taken my time to do this in 3 passes each cut, because again, this is maple. It's a harder material. It's a 1/4 inch bit. I got a little area here. I got these sharp little corners where it's going around the zigzags. I don't want to chip the wood. And then finally it's going to move back out of the way, and this is where we find the option of what bit we want. So here, first of all, this is a keyhole bit that will allow you to do a keyhole slot. You see this a lot on the back of plaques and stuff. And I've already cleaned out the spindle collet, put that in, and then zero that out. So notice that bit is wider at the bottom than it is at the top. If I was to try to plunge that straight down in there, that would wreck the material. And so besides the keyhole, here's another option. Since I was using round marbles for this, I didn't want to do it with just a straight keyhole. I took my straight bit out. Every time you take these bits apart, pull those apart, knock the sawdust out, push them back together, make sure they're holed. This one now I'm going to try with a round over bit, and hopefully that'll keep the marble in track a little bit more. And if those threads aren't going nice and easily, don't over tighten them. You don't want to strip the threads out on your spindle. And then get this guy zeroed, and you're ready to now make that cut. So let me pause that here, and we'll show you go back to the file. Alright, we've put the bit in, we zeroed it, and what we're using for this is we're actually going to do a fluting operation, and what we're going to do is this lead in and lead out with our box core round bit. So just to show you what the fluting is, first of all, that's a different toolpath here where you can flute from one distance depth of your setting to a deeper distance. So if when the marble extracts out of the puzzle, I want it to go down at a certain depth to come to its final resting place. So to preview that one, we have this 1/2 inch bit round over box core bit, and I will go preview that visible toolpath, and notice that it starts here shallower and ends up deeper. So that's the fluting toolpath. And I put that right before the box core because I don't want to do another bit change. So the way this box core is set up, again, this is a 2D profile toolpath. It's on the line. So when it's on the line, I can't use the add lead option for what I'm going to do because I've already got my leads built in. I've got my lead that comes out of my material here to this area that's already been pocketed down, and I also have it down here where it comes out past my material, which we'll see in the video. By looking at the profiles of those bits in that video, if I was to plunge those straight down in without having some sort of a lead in, it would damage the bit or damage the material. So that's where we've had to add those in. With the lead, though, we can't have the ramp added in. We're going to save the ramp for adding it to the exterior profile cut on this. So let's take a look at what that cut. So we put the ball nose, the box core in, and you see the first thing it's doing is it's doing the fluting, where it started at one depth and it's going down deeper. And that's so when the marbles come out, they'll just keep going down to the lowest point. And this again here, you can see this is set in 3 different depths. Didn't want to overdo that bit, cutting down in there too hard. So it's going to lift up, and it's going to come over past the material. It's going to plunge down to its depth, and then it's going to enter the material. For it to have plunged straight down into wood, that would have wrecked that bit or damaged the bit, knocked your spindle out of square, a lot of different things. So that's where a lead in is important here when you have certain profile bits. Also, when you want, like the earlier example with the rectangles being cut just for edge quality. But there's definitely certain bits out there where you have to have a lead in, and in this example also have a lead out, which this we can't have it off the edge of the material, but what we have is a pocketed area already there that is removed that it can go through and then pick back up. So there's a lead in and a lead out. And here it is being run with the box core. Tried it with the rectangular bit to see how it would run through there. It plunges down to this depth and then it enters in and goes. So that is more of an upside down T right there. And that upside down T is hidden down inside the wood, and that's what keeps the marble from falling out of the front of that board. But for that to lift up right now, that would damage your finished project, and a small bit like this on hard maple, it will probably end up damaging the bit. But this is a good example of a lead in and a lead out. So we've led in from off the material, and now where we're about to lead out of that cut is an area that's already been pocketed out. So it can just pick right up there. So there's a lead in and a lead out. Alright, the remaining toolpath that we have here is the profile outer. And that's profiling around the outside of our two parts. And since this is in Maple, I really want to add a ramp. I really want to have these tabs in an easy to remove location, and I'm going to show you the file. We'll run the final video and you'll be good to go and try this stuff on your own. So again, I've got a 0.85 cut depth. That's too deep to cut in one pass, so I've set my pass depth down. I'm cutting on the outside, but what we're looking at here are these advanced features. A tab. Just from experience, I know a tab with a length of 0.4 and a height of 0.24 with a 3D is a nice size tab, and it's easy to remove when it's with the grain. And also notice where I have these. I have these in positions that are easy to clean up. If you remember earlier in the video where they were down inside of a crevice, or if they're here on a radius corner that this precision CNC has done, you're just creating more work for yourself by now trying to recreate that by hand. So these right here are real easy to nip off, walk over to the 3-inch spindle sander and clean them right back down, and no one will ever see that they were there. I did not bother with adding a lead to this. Got a nice, I know my material's held down, and I'm going all the way around. I don't have to worry about, this is a compression bit I was cutting this with. I don't need to worry about leading it in or out. Ramps, I did want to add a ramp to this. The compression bit isn't the best bit for just plunging straight down in. And if you can add a ramp to it, which we will show you in this video here about this ramping down, instead of just plunging straight down, you can give this ramps a smooth ramp of a certain distance, which we'll show next. The zigzag is what we showed earlier on the pockets, where it was zigzagging back down to the pass depth. And then finally a spiral, which is a nice little corkscrew for doing like inside of circles and holes. And we can specify the distance on these. And then the order of the cut, I showed you earlier on the larger 4-foot by 8-foot material where we had several pieces on there. The order of the cut for me right now is not important, it's just 2 pieces. So I have it screwed in corners, I'm not too worried about the order. So these here can be used as many as you want or not as many as you need per project. It's all a matter up to you. But you know, tabs are definitely going to be necessary for hold down. Ramps are really nice for bits, and the spindles aren't designed to be, you know, plunging down into this hard wood. So if you can give them a little bit of a ramp to ease down in there, it takes away some of the vertical blow and then lets them just move laterally. And then a lead is always nice when you can come in with a certain bit. So let's go back and take a look at this cutting. And we've changed to the 3/8 compression bit here on this, and I also have got it zeroed, and you notice that it's ramping down over a 4-inch increment on that, because I had a 4-inch ramp where it ramps down in the Z, and finally once it gets down to the final pass, it's going to start picking up right there, again here, and what it's doing there is it's doing the tabs, and those tabs are what are holding the scrap material and the finished piece to each other until the finished cut. That small little piece without some sort of vacuum, that thing could kick sideways, and that could kick right into the bit and tear out a good chunk of my project. So as you can see here, it's ramping down over the 4 inches, and then it's just going and it's making 3 passes. So I didn't want to exceed 3/8 depth on these passes because I didn't want to break the bit off going into this hard material. So as it goes around, it now picks up for the tabs, and then it moves itself around and ramps down in the Z per pass. So when I get done, that picks up, and before you even unscrew this thing, you're going to want to make sure you cut all the way through. But let's just take a closer look here. You can see this thing ramp down in. So here, when it gets over to the other side, you'll see the Z just slightly, nice and easy. It doesn't even lose speed. It just ramps down in over 4 inches. Nice gentle slope like that. And now when it comes down and gets to the last toolpaths, it cleans out the previous ramp, and now you can start seeing it pick up for the 4 tabs. So it's going to come over here to the side, pick up, and there's a 3D tab. It barely slows down. It's a little ramp up, a little bit of a ramp down, and then that's where you get your 3D tab. So we've used a ramp and a tab to make the profile cuts for these 2 parts. And just to get you to come in here and see it a little bit nicer, what these ramps really are up close, is here was the zigzag ramp, where it's kind of zigzagging back and forth, and this is on a circle, so it zigzags around a circle, gets to that depth, goes around and cleans it out. Zigzags back down to the next depth, and then it'll go back and clean that all around. So it'll always clean out the previous ramp. And then here's on a longer one, where it ramps back and forth, comes back, cleans out the ramp, and then goes ahead and finishes the pocket at that pass depth. And then, since this is a 1/4 inch bit, I did it in 2 passes. Now it's going to pick back up, ramp again, and then go back down to the next depth. So ramps are real nice as far as wear and tear on both bits. And here again was showing the fluting, and it's having a ramp in the end of the flute. So it went back, ramped back and forth, and then came in, with the lead ends. And then you verify that your material has been cut all the way through with the profiles before you remove the screws, because with this method you're not going to get it back in place. Flip it over. You've got those 4 tabs that we put on each piece. Hopefully we've left the tabs big enough that they've held the part from moving, but small enough that I can just nip them away and go clean them up real easily by hand. So there's ramps, tabs, leads, order of cut, and there's just some advanced options that are built into the profile toolpath that will help you just make your project come up with some nicer features, cut a little faster, cut a little more efficient. Here's the thing finished in the end. The marbles aren't coming out through the front because I had added the leads in. I've added the ramps to save on my bits. So this is where we are with our advanced options of the profile toolpath, and hope you enjoyed today's training, and we will see you again here in 2 weeks. Thank you very much.